Alright, so let's talk about Venus. Venus is such an intriguing planet because it is so similar to Earth in so many ways. It's actually called the twin planet to Earth, and yet it's so different from Earth. I mean, it's the farthest thing from habitable that you can imagine. It's like the image of hell, whereas Earth is, it's home to so many different forms of life, and yet Venus is called the twin of Earth. And it's very intriguing because early astronomers really looked at Venus and looked at the clouds around Venus and thought that it's going to be this tropical planet with all these life forms and everything. Today we know that it's actually, like the image of hell. There are a lot of things about Venus that are really similar to Earth. For example, Venus is about 95% of the diameter of Earth. So Venus diameter is about 12,000 12,100 kilometers, and Earth is about 12,742 kilometers. So the size of both of these planets are very similar to each other, and not just the size, right? Their density is also pretty alike. Venus is 108 million miles. Million kilometers from the sun, whereas Earth is 149 million kilometers from the sun. It is a pretty big difference, but when you look at it in terms of how big the solar system is, or even like the relative difference here, it's not a whole lot of difference, right? But in spite of being similar in terms of dimension and density and the relative distance from the sun, they are very, very different planets. The first thing is, let's look at the atmosphere of both the planets, right? The atmosphere of Venus is 96% carbon dioxide, right? So most of Venus's atmosphere is carbon dioxide, whereas on Earth 78% is nitrogen, and then you have about 20% oxygen, and way over here is carbon dioxide, which is like 0.038%, whereas on Venus that is what is the major component in their atmosphere. And of course it has like 3.5% nitrogen, some sulfur dioxide, but most of it is carbon dioxide. And the pressure on Venus, the atmospheric pressure on Venus, is about 90 times what you'd feel on the deepest ocean on Earth, right? Deepest ocean on Earth is where you would have the most pressure, where you'd feel the most pressure on Earth, and that multiply that by 90 times, and that's what you feel standing on the surface of Venus. Earth and Venus, an interesting fact that people who advocate that climate change is really bad want to point out is that Earth and Venus almost have the same amount of carbon dioxide when you talk about the total mass. Not about the carbon dioxide in the atmosphere, but the amount of carbon throughout the surface, the core, the atmosphere, everything. But the difference is that most of the carbon in Venus is actually in its atmosphere. As we saw, 96.5% is carbon dioxide, whereas on the Earth, most of the mass of carbon dioxide is actually inside the Earth. So it's like inside the surface and the core, and the atmosphere really has just 1% of what carbon is present on Earth. So these people who really advocate that climate change is bad kind of point out that if we keep on pumping out all the carbon from the surface and from the surface of the planet, and we keep on burning coal and fuel and fossil fuels to put all of this carbon dioxide into the atmosphere, then we're going to have a similar fate as what Venus is going to have. And I mean, that's something to think about. When you have the same amount of carbon, it seems like if we just keep on doing what we're doing and we keep on, putting all our carbon dioxide in the air, then at some point we're going to have 96.5% carbon dioxide, and we probably are going to face the same fate as Venus, or are we? We'll get back to that point. But just to give a little bit of context here, in the early days, as I said, early astronomers, they saw a cloud around Venus. They thought there's a lot of activity going on underneath these clouds because we cannot see the surface because of the thick, dense atmosphere that Venus has. And they kind of assumed that Venus is a likely candidate for a habitable planet. But as as we start, in fact, they were so convinced of this that early missions that we sent to Venus were actually designed for a splash landing. So we thought it definitely has, or it probably has water on the planet. But after many repeated failed missions, the first successful one to land on Venus was actually Venera 13, and this was actually in 1982. And this probe actually landed on the surface of Venus, and it actually took a photograph of the surface of Venus. So this is actually the photograph. So I think this was the photograph that that was taken, but then they kind of added color to it, and this is what it looks like. So you can see all these rocks on the surface of Venus and everything. It kind of looks similar to Earth, but it cannot be farther from the truth, right? Because as soon as it took this photograph, Venera also started recording, the different components like the composition of the atmosphere, the atmospheric pressure, and all the things that we looked at earlier. And once it started looking at that stuff, it became pretty clear that Venus is just hell. And Venera 13, which was actually built to, withstand really, really harsh conditions, it was built to withstand the melting point of lead, also couldn't withstand the surface of Venus. It died 127 minutes after getting into Venus. So it's a very harsh place, Venus. And the thing is, Venus once might have been habitable. And the way we know this is because as Venera was gathering all this information, one of the things that it noticed was that there was hydrogen isotopes in the atmosphere, and that means there should have been water before. So what exactly happened to Venus if it was habitable? Well, there are a couple of things that scientists currently believe. One of the things is that the sun started getting hotter at some point in the past. So the sun was a much cooler star in its early days, and that's when Venus was probably thriving with all its water, and probably it was a habitable planet at that point. And then the sun started getting hotter, and that's when Venus really started becoming the hell that it is today. And what happens when the sun gets hotter is that the water vapor on Venus starts increasing, right? So we have a water cycle here where water evaporates and then gets back to the surface. But on Venus, the problem is that as water evaporates, there's also all this carbon dioxide and all these greenhouse gases that's trapping the sun's heat and making the planet hotter. And water vapor itself is a greenhouse gas. So as the water vapor gets into the atmosphere, it doesn't have a way to condense and fall back to the surface, because the sun's heat is getting trapped and it's so hot that the water vapor remains in its vapor state. And this kind of leads to a positive feedback where you have water which becomes water vapor, and then after becoming water vapor, it generally has to go back to water. But before it can do that, there's the sun's heat, and then there's all the CO2 in the atmosphere, which is a greenhouse gas, so that traps the heat. And instead of this water vapor going back to water, it's so hot that before it can turn to water, it just goes back to its water vapor state. And this water vapor is again a greenhouse gas, right? This is a greenhouse gas. So if water vapor is trapped in the atmosphere, along with this, if water vapor and CO2 are both in the atmosphere, increasing the greenhouse effect, then they both trap the sun. They both trap the sun's heat and they both increase this sun's heat. So it kind of leads to this positive feedback where there's more water vapor, because of which there is more heat, because of which the water vapor cannot become water again, and it just keeps on trapping the heat and gets hotter and hotter. And that's one of the reasons why Venus became such a hellish planet. The other one is, so the first one, as I said, is sun getting hotter, and the second one obviously is the greenhouse gases itself. It has all this CO2, and then on top of that it has all this water vapor, and then it has the sun getting hotter, this sun's heat entering, and then the greenhouse gases not letting this heat travel away. So and the third one is this water to water vapor positive feedback, right? Feedback loop. So it just keeps on increasing. And then if the water vapor could have condensed and become water, and this water is kind of a coolant, right? It kind of absorbs the greenhouse gases and it absorbs the CO2 out of the atmosphere and kind of leads to a cooling effect. But if that cannot happen, then all the heat just gets trapped. And there's the planet, there's the heat coming in, but then there's no way for the heat to leave because this atmosphere is trapping all the heat. So this atmosphere, CO2, water vapor, all this stuff is just trapping it. The third reason is that Venus also had a lot of volcanoes. So one of the probes that we sent to Venus, a few years after the Venera probe was the Magellan, and what that observed was that Venus was actually 85% covered with volcanoes. Of course, they weren't like active volcanoes at the time that Magellan observed it, but we could say that these volcanoes were actually very active once upon a time. And what volcanoes do is they emit gases, right? And what are these gases? These are all greenhouse gases that it emits. So like CO2, water vapor, methane, all of these gases are greenhouse gases, and they also lead to the heat being trapped within Venus. So as time passed, there was no way for this heat to leave Venus, and Venus became a hot, boiling planet. In fact, Venus is so damn hot that it is hotter than the closest planet to the sun. So if you see Mercury, which is the closest planet to the sun, you would assume that Mercury is the hottest planet, but Mercury is actually 430 degrees Celsius, whereas Venus is 471 degrees Celsius. And that is the hottest in the solar system, the hottest planet in the solar system. And that is very intriguing because it's not even as close to the sun as Mercury is. And all this greenhouse gases converted Venus into this hot, hellish planet. So the big question then is, would the same happen on Earth, right? Well, one of the arguments, as I said earlier, is that we have the same amount of carbon, but in the core and surface, whereas on Venus it's all in the atmosphere, right? So if we keep on doing what we're doing currently, which is burning all the carbon and creating all this carbon dioxide in our atmosphere, will all of this global warming, this is what global warming is, right? So if we keep on doing all this, then will the global warming eventually convert Earth into a planet like Venus, where we trap in all of this heat that comes in from the sun and not allow it to go away? So that's the argument that many of the climate change activists kind of present. But from what I've read, that's not really accurate. I mean, yes, global warming is bad and we should try to stop it. There are a lot of bad things that can happen because of global warming, but that doesn't mean that Earth will become as hot as Venus just because of global warming, right? It could become because of a lot of other factors, like the sun suddenly growing warm, or a lot of different changes that can happen in space. But just because of the global warming and just because of global warming and because of carbon dioxide emissions, I don't think that that's enough for Earth to become as warm as Venus. Well, first of all, the thing is, Venus didn't have as much water as Earth. Earth is 75% water, right? So for a planet as wet as Earth is, it's not very likely that something like the situation in Venus can happen. So what global warming will do to Earth is it's going to increase the ocean levels. A lot of land is probably going to go under the water. There are a lot of adverse effects. I'm not saying global warming is not bad, right? It'll lead to droughts. Hurricanes will get stronger. Heat waves. As I say this, I'm actually recording this during a heat wave in California, where there's also like a lot of smoke in the air because of the wildfires, and the sky is actually yellow. There are a lot of adverse effects of global warming, but in order to get to the point that Venus is at, global warming is not going to do it. That's what I can see from all the things that I've been reading. And the other thing is that Earth may have the same amount of carbon as Venus, but as I said, only 1% of it is in the atmosphere. And although we can continue to burn all the fossil fuels that we have here, but most of Earth's carbon is in the core. We're not going to be able to just extract carbon from the core of the Earth and burn it. That's not possible. So it's not possible that we can get to like 96.5% CO2 in the air like Venus, but that doesn't mean that we should just ignore global warming and just keep living our lives global warming is not an issue. It is a big issue, but it's just not enough to convert Earth into the 471 degree hell that Venus is today.